Today we are celebrating 100 subscribers. So first of all, thank you all. And yeah, it is amazing. And the idea is to have a chill out streaming, so where we talk about different interesting stuff about AI, but not only machine learning and usual stuff in this channel. Yeah, the new thing here is that you can see I have introduced a streaming program, so we can check all the checkboxes and going ahead. So yeah, good. Exactly. So yeah, I'm receiving notifications, so we are actually online. Good. First thing first, we need to go through the list of things to do. And the first thing that we need to talk about is, okay, how amazing is having a community that is growing, but also, last but not least, we need to discuss something serious. Okay, so this is my serious phase. December 2nd to 6th, so the first week of December, we will hold in Bologna a computing school for undergraduates, graduates and PhD people that want to get started with using cloud tool for data science, basically. And this school is called SOSC, so International School for Open Science Cloud. And the idea is to provide all the expertise of these institutions, so INFN, that is and the ICSC, that are the entities for which I work, and also the other organizers are the University of Perugia and Bologna, are organizing these courses with the idea that, okay, we need to fix the gap that we have, fill the gap that we have in many schools for computing, so too much concentrated on computing stuff, and too much, or in alternative, too much focused on science part. So we need something to merge, we think. And since we are on the 6th edition, I think we were pretty close with the intuition. And so yeah, you can find here at the link I can put into the chat and then into the description all the details for this school. So don't miss out on this, and let's keep it. Yeah, I put in the description. So, but if you look for School of Open Science Cloud 2024 in Bologna, you should be able to find it. Okay, cool. So this was the first thing I want to highlight. We will be there in Bologna, creating projects starting from a real case, use case in science. But yeah, this is not really important. The important thing is that you have a project, and we will merge the knowledge with all the cloud tools with what you can achieve in science with those. All right. So yeah, I already talked too much for being a chill out instance. So the idea again, let me just checkbox the first one. So the introduction to Open Science School. If you have any comment and any question, you can drop a message. And yeah, so just a second. It's a difficult streaming today. Okay, I checked the first box. Now we are left with another one that is starting with AI challenges. All right, so I take my whiteboard because we need to be a bit clear to set the stage for what we are going to do today. First thing, we are going to take some challenges. For instance, the first one will be transforming a pod into an Helm chart. So a list of pod or manifest in Kubernetes. I want in output an Helm chart, okay? I want this Helm chart to be as complete as possible. We may want to introduce values that maybe AI is missing, and so on and so forth. So this translation will be done by AI. In this case will be OpenAI, okay? How we do this? Well, we are doing this in the following way. We're taking a scripting approach, and scripting approach will be managed by a technology that is called GPTScript. I already talked in the channel, don't worry, we're going to reintroduce what it does and why it's useful for this kind of challenges and why we're applying it in this case. So yeah, just imagine that is not a bash script, but it's a bash script for AI, okay? So we are trying to use this tool here and make it, and make it useful. So saving this bash script ++ in a way that you can reuse such tool for different pod to Helm application. Okay, so at the end of the story, if we manage to check all the boxes that we have in program, you will be able, yeah, that's a pity that I was in the wrong scene. Sorry about that. So let me resume. Be patient. I told you it was a difficult one. So yeah, you see now, you start with a pod, an Helm chart with some. Then you have OpenAI scripted through the GPTScript that allow you to reuse pod and Helm. So this is the first challenge. How we do that? Let me introduce, first of all, GPTScript. GPTScript is this script. So the idea is pretty much this one. You create a script that is in a certain form, okay? When you say, okay, I want to use this tool that are the Lego block that you can store and reuse later, you can pass all the context you want. We use the context, for instance, in the example of the pod transformation to Helm. Our pod is the Helm input. So we want our script to take an input, the pod, and translate it into an Helm chart. And then you can select if you want to have an assistant or if you want a standalone tool that you can run in many other times and distribute that. If you need an assistant, you can activate chat true and you can tell the AI to do and to serve you in the best way possible. So cool. It's harder to say that to try, so what about starting with trying it? So let's jump into our backmule instance and all right, so now we should be able, no, we can't. Are you there? Yes. Okay. So let's take a look at how GPTScript is working. So, okay, I stored in this path some helper to get started, right? So if we open this, we have different GPT files that are that has the extension .gpt. And for instance, if I want to create an Helm chart from a pod or from a manifest, we need first of all the manifest, right? Whoa. So the manifests are in fact, let's take a tool that already you might already knew if you follow this channel. That is the interlink tool. So if we go to cd interlink CI manifest, what we have is a list of YAML that we can use to bring up different components. One component is called the virtual kubelet, and the other component is called the interlink, right? So now the idea is, if we take this set of manifests and pass them to our AI as a workspace, as in terminology, in GPTScript terminology, but you can consider it like to say it, like a context. You can take this file and say, okay, just bootstrap an assistant for our needs that is aware of all this manifest and make it transform this manifest into a complete Helm chart, right? So this would be awesome. I think, how many times you develop something in a manifest and so on and so forth, and you want to transform this into an Helm chart? Yeah, it's I cannot count how many times it happens to me, and usually it takes several hours of works because you need to debug and to remember exactly how to do that. You know, maybe you start from Helm init and you have to insert all the values and templating your templates, of course. Yeah, so what is the point? The point is that we can think of something like this. MV oops, come on, pod to GPT. Okay, so I say build and build assistant. This is the name of my script. Then I put a brief description of what, to help you transforming. This is not right. Transforming Kubernetes manifests into a Helm chart. Okay. Then, okay, cool. Then you want to pass the tool that you need. All the tools that you need at this time are the GitHub context workspace. That is the one responsible to bring with you all the folders that you need. And then we say, okay, this is an assistant. And I show you in a second why it is pretty cool. All right. Then. Here start the scripting, okay? So you introduce the task to the AI. And usually it works pretty well if you start saying AI what should be impersonating with. So in this case, we make clear that the AI should act as a DevOps translator assistant, and it should help people creating Helm chart starting from Kubernetes manifest. Notice that I'm not writing a single line of code, okay? I'm just relying on OpenAI functions to understand what they had to do at the system level, okay? And then take this information from the current workspace, and whenever you start, introducing yourself and ask what you can help with, okay? So this is pretty default. You can find this in the guide, so you can quite easily get started with this kind of information. And I just like to show you how powerful is this simple script. Okay. Oh, come on. Okay. Not a single thing is going good. Come on. Okay. So right. This is the way you execute GPTScript. First of all, sorry, I missed one thing. Of course, now I have this installed, but to install GPTScript is enough to do brew install if you use brew GPTScript, okay? And you need to pass in the environment variable your OpenAI key, okay? So I'm talking with OpenAI. You can use also other models, there is support for that, but so far I find myself very confident in having the best answers from OpenAI stuff. That's the situation. Maybe will change in the future. Okay, so brew install GPTScript. I already did that, so we don't need this anymore. And then, oops, GPT. So we can start from passing the workspace with a manifest and then saying to the GPT script, okay, look, take pod to Helm GPT script, become my assistant for transforming these pods into an Helm chart. Okay, let's start. So hi there, I'm DevOps Translator Assistant. I can help you convert Kubernetes manifest into Helm chart. How can I assist you today? Okay, first of all, show me the content of your workspace. Okay. So yeah, every time you will interact with your file system, GPTScript will require you to confirm the operation. Okay, this is sound. So, all right, you allow him to look into that folder, and voila, you have the content of this folder. Now we have this, all we need attend, and we can start asking, okay, transform, take virtual-kubelet.yaml, virtual-kubelet config, service account, interlink, an interlink config. Okay, let's, oops, and create a Helm chart in a local folder with a unique ID. The name of the chart. So let's tell him also to use this. The name of the chart is interlink, and in the values you should put an enabling flag for the interlink component. Okay, so let's see what it should be able to do right now. Okay, first of all, it's saying if it can read the content of all the files that we are requesting. So yeah, you can. I told you can. Okay. Now it's creating an Helm chart structure, pretty valid, with a structure that we like a lot. So it's taking these templates. Now let's see what it does with the values. Okay. So first thing first, the template for the configuration. Okay, I don't like too much this because it's not templated, but fair enough. Okay. Then neither this one is templated. Okay, let's see where we go. We're going to assign a vote from 1 to 10 to each one of these attempts. So, okay. Yeah, I don't like at all what we got. So, let me check. So, yeah, if we go into CD, interlink, first of all, it doesn't understand what it means unique ID, but okay. Then values, yeah, it only has these values. So no, nope. Try harder to create an Helm chart with all the reasonable set of values in the templates. Okay, so it's reading again. It's introducing, oh voila. Now it's introducing values. I think we are now closer. That's cool. Okay, so yeah, you might need some iteration together, but imagine how much time you needed to do an operation like this. Okay, so exactly. Now he wants to write down these, okay, and do all the edits. Fine with that. Okay. Now let's take a look. Mvim values. All right, now we got it. So you see here now we have a lot of values that hopefully we are going to put into some nice templates. So templates, let's take one, for example, virtual kubelet.yaml. There are no templates here. Not good, not good. Okay, one last try. Start from scratch and create a chart with the same chart starting from the same manifest, but in a folder called interlink retry. Okay, let's give him another shot. Last one, then we go for the vote and we pass to the next item. Okay, so read everything you need. Go ahead. Not template whatsoever. Okay. So okay, now it's writing stuff. Okay. So service is templated. The name chart.yaml is pretty accurate. Okay, good. Then we have values are pretty accurate again. Cool. Then, okay. Deployment looks good, not perfect, but good. Because there is the image as a value, we can add some more, but yeah. A config map is completely templated. Cluster role doesn't need it, so yeah, let's take a look. So now here we should find something like interlink minus retry. Vim and okay, and then we say CI manifest interlink retry values. So okay, values are good as before. So chart is saying correct thing, and then we have deployment. Okay, we have containers interlink and only applied if enable is true. So yeah, pretty good. Then we have deployment kubelet interlink. Okay, with replica count set from parameters. Name. Okay, we don't have too much templating in here, but yeah, quite good. Well, we are missing service account, and where are the where is the configuration? Not good, not good. Yeah, we missed the configuration. So service account service. Where is this? Where is this? Template config map. Maybe. Are you kidding me? So vim templates. Config maps. I don't know why I couldn't find before. but yeah, pretty accurate. So values virtual kubelet config interlink. Cool. Now you want to see something very, very cool? We can ask something like this. Look. All right. Add inside add a GitHub action that stores the Helm chart as an OCI artifact inside GitHub container registry. Let's see. All right, cool. Starting good. Interlink retry. Looking interlink retry. I don't know if it's true, but yeah. Helm package and push. Okay. Come on. Oh, can you move the folder inside the no, can you move the GitHub actions and the Helm chart into a brand new folder and initialize git repo. Come on. I don't know how I did it, but okay. So I want the AI to move my folder in a separate, my chart in a separate folder with all my actions. So, okay, let me see if it understand what should be done. Yes, you have to copy also this. Oh yeah, all of this. Okay, you see we hit the rate limits. So sometime happens, but yeah, don't get. Okay, we take the occasion to summarize what we just did, and we give a summary. So we start from a manifest folder, and we ask GPT script. Cannot write in this position. So okay, a GPT script, create me a Helm chart and also a .github action. Okay, so not only have a chart to start with all the values and a basic template after some try. Remember how much time it would take to do from scratch by end, okay? So keep this in mind. A GitHub actions to store this into an OCI, so into the GitHub container registry. All right, so we have everything. and we can say retry please. Okay. Limit 32 used. In 8 seconds. Okay. This is something never happened before to me, but okay. Never mind, never mind. So what we can do is do this simple copy by hand, okay? So let's relax a bit and let me put a mark to this try. So pod to Helm chart. I would say this is for the experience, this is a 6 out of 10, okay? Decent. It's not so simple. Definitely has some issue here and there, but we can work something out with this, okay? Then, okay, so just to check here in manifest the GitHub workflows publish, we have this, so our GitHub action setup. I need, probably is 5 out of 10, okay, in our pod to Helm chart category, because it's not that, let's say, correct. Then, if we want at this point, we can store this into a repository and start work with the Helm just created. All right, cool. Now, let me just, okay, I don't want to log in right now. All right. So let's exit for now. And let's jump into another challenge. The other challenge is taking information from Go files and translate them into OpenAPI. Okay, so how should we do this in GPTScript? Easy peasy. So Go assistant. We say this time you're a code assistant. You should use information you have to create interfaces for whatever the user requires. So this time we can say, okay, bring with you all this information, take a pod to Helm. No, our information are Go assistant. So GPTScript Go assistant. How can I assist you? So can you find in the workspace the files responsible for the interlink server REST API. So we want, for instance, we have a REST server, we want to AI to generate our OpenAPI specification and maybe also create a client for this OpenAPI infrastructure. So the idea is, okay, I create my server. I want you to automatize the documentation of the APIs and the client in Python or whatever language you want. So let's see, first of all, if we can find all the information needed. Exactly. Now you found the correct command.go, and then you need all access to all this information that comes from the API package. All right. So, okay, read all the interlink REST API files and generate a valid OpenAPI JSON specification. Yeah, let's see how it goes with this. Okay, so it's taking a bit. So log options, secret, config map, all pretty accurate. All the chain, this is a complicated stuff, a complicated OpenAPI specifications. It's not easy, but yeah, the schemas are all there. For instance, let me look at create. So create a new pod. The request body is pod request, correct? The response can be pod created successfully. Okay, the create response is not correct, I think. So it's update cache, components, schemas pod, but the pod schema, oh, here it is. Okay, first of all, let's take a look if this is a valid OpenAPI spec, right? So, would I need to say open? Yes, please. Do it with a unique name. Okay, come on. Come on, guys. Okay, it's not that unique, but fine. So now we have this file that we can copy and try to see if it's a valid JSON. The easiest way I know is Swagger editor. I must admit, I do not think that we're going anywhere with this. Okay, so the only thing that is wrong is get long request body, because get cannot have a request body. Okay, makes sense. So let's try to see. All right. So I think that all in all, not bad at all. Not bad, not bad. All in all, we have only the logs. Oops, only the logs code that is not correct, or at least it's not working. We don't know if also other stuff is not working. So, right. Then, let's try to fix this. Please check get logs call. Get calls cannot have a request body. Okay. Okay, now it's saving the result. Pretty good. Let's go. Let's go. Okay. So V2. Let's open the V2. So let's take a look first of all if log, sorry for the scrolling. He corrected it, saying it's a post. All right. So let's see if this time he got it correctly. Okay, come on. Yeah. So let's go back to wonderful. So yeah, we just produced a pretty good awesome. Look. It also looked up to the Kubernetes stuff and show all the information that we need. Oh, that's awesome. Cool. Okay. That is pretty better than the one before, huh? Because so we check this box and we put, I would say 7. Oops. I would say 7 out of 10. Okay. Then we didn't finish because now we can do something even cooler. So create a Python script client for this open API spec templating, demonstrating how to use each call, each REST API. And store it into a file. Okay, so it's creating all the requests. It's filling out all the mock information, and voila. Confirm, yes. Yes, interlink client. No, come on. We were almost there. Ah. Okay, we need to wait a bit. So, but we can do this. Haha. Can select this and vim interlink test.py. So we can pass and say okay. Oops. Okay, so I don't know why it's not loading, but okay, it's not loading the syntax, but can take a look. So base URL, get status is a post, here is a get. I can tell you I'll wait this thing. So yeah, you can start from something like this. You cannot get too much done yet. But you see, okay, pod data are generated reasonably good. Although containers, init containers and volumes are not filled up. Okay, it will need some work, but you can get something working. And yeah, so then, okay, FluxCD to Helm, we can check this is not useful at this stage. What to me lately created a lot of useful stuff. It's okay, I have a Dockerfile, I want to translate all the instruction into something else. This something else is an Apptainer file. So yeah, just to be clear, the Apptainer files are useful maybe only if you want with HPC centers, because Apptainer Singularity is the container runtime for HPC center in general. So if you have a batch system with this kind of container runtime, and the weird thing is that you need usually to create a proper image for Singularity or Apptainer to run different Docker files, okay, that are Apptainer reference file, if you wish. So what was useful for me is starting from a Docker file that looks like this, and vim Docker runner. So starting from this, that is quite complicated runner in here, and create a script, a GPTScript, to do the transformation. So this is not a chat, so it's just one go application. I have not, so my application that say, okay, take this Docker file and translate this into something more. So understand the Docker file first, then if needed, convert it into a single stage build, and then do different steps. So don't forget to keep all the build steps, don't forget to do the files to import, and so on and so forth. So how you should run this, starting from your Docker run, simple like this. So start from my local folder, workspace is my local folder, look for Docker run in here, okay? So no, pretty different. So go into Helix and okay, and then we say transform Docker file dot runner, only this Docker file, okay? So this will start creating a reference file for Singularity. You don't need to know anything, literally anything, and it will run this for you. Okay, so this is the output. Okay, path to source is the current workspace, is referred to the current workspace. Okay, let's see if it's no. I'm just trying to push it to no, I don't like it. So let me try one more thing. Okay, so start from this, transform Helix. Let me remove this and we should be good. Okay. Now so first of all, let's try it like this. Okay. Okay. So without argument, it looks like the best solution. And so we go inside Helix and we do mvim Apptainer ref. So, okay, you can see that it set the tag as always, install all the stuff, and then do the compilation. I can tell you already that this solution works pretty well, because now we can actually build our image following these steps. And okay, importing correctly, and eventually Holy cow. Again, the scene. Sorry, it's a different setup. I cannot get to work it properly. So let me summarize what I just did. Oh my gosh. Okay, so while it's building, you can see that the build is going quite nicely. This is how GPTScript worked. And my prompt was, okay, just look at the workspace apptainer.gpt, and that's all. So now I'll make you take a look at what are the different behavior, but yeah. Ooh. Okay, so now it's installing, but while it's installing, since I was completely obfuscating the screen, let me recover what we put into apptainer.gpt. So in the description, the workspace as before, Dockerfile, and then we say, okay, read and understand the Dockerfile that you find in the workspace and do this particular step to translate that container image into a Singularity image. Okay, cool. So after that, you need to go farther. That what means we give it a try and we are creating a correct image. That's awesome. So this worked, although you missed how this worked. So okay, not so cool, but not bad either. Okay, now this is the camera that I wanted, and I want just to update our, okay, here the vote, I would say 8 out of 10. Okay, so we are quite above the hour of the streaming. So I propose some break. So I'm breaking just a few seconds, time to go to take something to drink, and then we resume with a different topic. All we have done so far is done via OpenAI, but with the technology that we just saw in these examples, so Interlink and Helix, we can bring the best of two worlds together. So Interlink allows you to go into an HPC center and have all the resources that you find there in a seamless way, so in a Kubernetes native API way, but underneath you are going to need to run Slurm or batch jobs, so batch jobs that simulate the container execution. And on the other hand, you have Helix that allows you to have a central hub for developing your GenAI application, and at the same time, okay, now this time it's time for the whiteboard, and at the same time you can have your runners, so your application that are actually responsible to run the inference for the GenAI stuff somewhere else with the minimum requirements. So just like really GitLab runner, if you know, or GitHub runner. So you have your central hub here. You have your GenAI hub that is based on Helix. Okay. And then you can manage through a Kubernetes cluster different runners that can be either physical, so you have a GPU locally, or you can have a virtual node. Okay, a virtual node that, thanks to interlink, can go and run into a huge HPC center. Okay, so imagine how much GPUs you have here that you are not accessing because it's running through a batch system. Okay, now you can access them through Kubernetes and make them connect back to the hub, to do inference. So it's too good to be true, I can understand, but trust me, it works. It works. So just a few seconds of pause and then we resume. Alright, here we are again. So let's take a look immediately at Helix. So I just installed in this cluster here. So let's do come on. Okay, okay, right. So I just installed on my Kubernetes cluster with Helm from the documentation, the hub, right? So the hub, you can see here, you have a lot of utilities to do RAG if you want to fine-tune stuff. It's a very powerful all-in-one GenAI platform, right? And this is also hostable on-premise, or you can also get it from services, software as a service. But yeah, pretty cool. It's working just like if you want just to use the interface. It was just like ChatGPT. You can generate text, image, or whatever. You can make it learn your input files if you wish. So you can do a lot of stuff. And you can also integrate that with GPTScript. So you can create scripts that you can then use as an entry point for your application. Imagine you want to do this kind of operation, so transform a set of manifests that just like we just did into an Helm chart as a service. You want to create a web service for this. It's quite good now that you say so. It might be an idea. You can do that with GenAI, for example, or with HelixML, for instance. You can create a server that exposes a GPTScript as an API. Or you can do a lot of different things. But one, you need computing power to do that, right? So here the dashboard, these are the operations I did before, but we are out of runners. So here on this side, you cannot see anything right now because we had to create a runner. You will find all the runners that are ready to digest operation to be done onto the GPU available. And to do that, we are going to create a runner. Simple like create a pod. Okay. So simple like this. Creating is pending. So let's wait for it to go running. Okay, so it's running and voila, now a runner has appeared. It will have an A100 GPUs underneath, so it should be ready soon, quite soon. Let me. Okay, so it's running. Yes, the operation of the bootstrap will take some time to get ready because it has to download all the models that is using. So the Mistral inference and so on and so forth, the old Llama stuff, etc. So this bootstrap can take a while, but meanwhile we can say, okay, hi, where are you? Okay, and this will create a queue of work to be executed. You see now that Olama is taking care of answering our questions. So soon after initialization, you can find an hello, I'm Elena, and all this kind of stuff. You can also, if you wish, create an image, for instance. So image, create a picture of you. Okay, so just 1 second. All right. So again, it will take some time. We see the dashboard. We have another kind of running process. And let's see how it ends. Then I can continue, okay, tell me more, and so on and so forth. So you see it's exposing. Now this is taking a bit because it has to load yet another model to do the inference, so it's normal, while this is already loaded and ready to go. So right now you have pretty functioning playground to do all the GenAI stuff that you want. And one thing that we are going to do into a dedicated video and our next streamings is to discover where this runner is running. And guess what? It's running on a virtual node. So this is actually a pod, but it's not running on this cluster. And we are going to see soon how this is possible. I'm so excited for these two worlds to come together, and I think they are coming quite nicely. So we will have for sure other material on this. All right. All right. So let's take a look at the list. We have on-prem GenAI and run. Cool. I would say that after 1 hour and a half of work, we can go ahead and say that we are almost done. We are almost done, so much that I think we can conclude. Don't forget, if you are interested in looking into the Open Science School, it will be a lot of fun. So if you're a student and you're interested in this topic, it will be definitely a good occasion for you. Don't forget to comment if you have any questions on any of the tools that we touched. We go pretty fast due to the time we had, but I hope that we look at enough detail to get the idea of what you can do. Something was a surprise for me as well, but I think with some iteration we can produce some good stuff. I wonder how this GPTScript that we just tried can be converted into actually some nice service, online services. For instance, I upload a folder with all my manifests, giving me back an Helm chart. Well, now that I say, it's quite interesting. Oh, I give you the code, tell me, and the OpenAPI is back. Oh, come on. We can do it. We can do it, and I'm working on this, and I'll let you know how it goes, okay? So, have a nice day. Thank you for following the stream, and keep up with the go.